Okay, so we have sufficient number now, so I think we can start. So prior to that, have you people submitted your assignment? Some of you have not submitted. I'll say actually three people have not submitted. So they are Shubham Das, Kumar Zaidip Kashyap, and Andreas Sharma. So what happened to you people? I think Shubham, I can see you in this call. Why have you not submitted your assignment, Shubham? Hello, Shubham. You have not submitted your assignment yet. What happened? Today you will submit. Saidip will submit today. What happened to you, Saidip? Why didn't you submit on time? On or before time you should submit, na? See, this is a professional course all of you are taking, right? So as in this during these 4 years of your study and stay here, actually you should develop the professionalism. Okay, and one of the very vital ingredient to be a professional is apart from all those ethics and all, okay, you should be like you should take care of the time and all. Okay, you should be able to manage the time. See, whatever like 15 your other 15 students, your friends only, they are also having the similar kind of task that you have to do, right? So that same within the same time. So if they are able to do, you compare with them. Compare it always with the good factors, the motivating factors. Okay, then only you will be able to progress. Otherwise, if you see think suppose okay he has also not submitted and all that way, if you think then it will be problematic. So always compare it the best and try to achieve it. Okay. So those who have not submitted, submit it by today. Otherwise, I will not accept. Okay. So now, after the last class, anyone having any doubt, any question? So, in the last class, we are discussing about we have solved some problem, okay, regarding gear drive. And one of the problem was from gear train also, compound gear train, a simple problem. So, today we'll be going through another problem, which is somewhat similar to the problems already we have discussed. So, we will be able to go in a faster pace, I think. So, now we'll be going to the question. So a pair of 20-degree full depth involute spark gears having 30 and 50 teeth respectively of 4 millimeter module are in match. The smaller gear rotates at 1000 rpm and you have to find the sliding velocity at engagement at disengagement of the pair of the teeth, and next is the contact ratio. Now, in this particular question, how this particular question is different from the previous question? Here, apart from contact ratio, which already it's a kind of common, by this time it's common for us. Already in too many questions already have seen how to find out the contact ratio and all. So apart from that, there is another concept of the sliding velocity at engagement and at disengagement you have to find out. So in that particular case, you should know what is sliding velocity or what is the how we can find out the sliding velocity. So prior to that, all those whatever is given, we have to uh, go through them and find it down. Okay. So what is given? So 30-degree and 50-degree respectively means, so bigger wheel we generally consider as the gear and the smaller wheel we consider as the pinion. And in general, by looking at this number of teeth directly, we can denote the gear and the pinion. So T suffix G, that is number of teeth in the gear, it is 50, and PP, that is for pinion, it is 30. Okay. Then this 20-degree angle, it is nothing but the pressure angle phi, right? So we have to find out that pressure angle is given as 20 degree. Module is given as 4 millimeter. M is 4 millimeter. And the smaller gear, it rotates at 1000 RPM. Smaller gear means we are talking about the pinion. So N1 we are designating with, so it is 1000 RPM. So that pinion is nothing but the driver, okay? So the pinion becomes driver here. So now from N, we can find out the angular velocity for this particular wheel pinion. So if by the omega 1 equal to 2 pi n1 by 60, this suffix n1, it is for the pinion. So from here, we find out this to be 104.7 radian per second. And always take care of the units, okay? You have to use the proper unit. Otherwise, actually in science and technology, if you don't specify the terms with their proper unit, it's actually meaningless, okay? So next, what we know, we have this given data about the number of teeth in the gear and the pinion. Okay, So from there, the velocity ratio we can find out. And we know omega 2 by omega 1, we can write like T1 by T2 in terms of the number of teeth. It is just the reverse. Or also, you can use TP by TG also, no problem. 1 and 2, they, this suffix we are using for the driver and the follower. Okay, that is the pinion and the gear. So either 1 and 2, T or P and V, whatever you want to use. Okay. So from there, very easily, we already know about this number of teeth, T1 and T2. We just found out omega 1. So from here, we can find out omega 2. Omega 2 be 62.82 62.82 radian per second. Next, what basically is required? We have to find out the sliding velocity at engagement and at the disengagement of the pair of the teeth as well as the contact ratio. Now, Now we already have the expressions for, we can standard expression for finding out the addendum of the pinion as well as addendum for the wheel, that is the gear. Okay, so already we already have this standard expression, so directly we can use. So addendum, how we can find out? So it is for the pinion, so these are the suffix are for p. Okay, p for p stands for pinion, and from there actually all those whatever p etc that we are using, so the corresponding number of teeth in the pinion we have to consider, and whenever it is pinion, so the standard expression we already have, which is given by the addendum value equal to mtp by 2 whole into that to the power 1 plus v into 2 into whole into sine square theta pi. Okay, that is under square root. Okay, minus 1. Okay, so this is the standard expression. Okay, so from there the known values we can already use. So this m already is given, number of teeth it is already there for the pinion. 1 is 1. G is what? G is nothing but we already have the gear ratio. Okay, so we already we have the gear ratio, and the gear ratio it can be found that from the number of the teeth in the your wheel divided by the number of teeth in the pinion. Okay, so gear ratio is nothing but Tg by TP. So here this TG as well as TP it is already given. So directly we can use this particular value. Okay. So that we are using now these values, and phi is the 20 degrees full depth angle, it is already given. So we are just using them, and addendum for the pinion is found to be 18.857 millimeter. Okay. So addendum in millimeter. Next, similarly, we can find out the addendum for the bigger wheel also, that is the gear. So in that case, how it is different? So the number of teeth has to be replaced by the corresponding number of teeth in the gear, and this Z, the gear ratio, it is the reverse. It becomes reverse. This is how, if you can recall one of the expression, the other expression you can just remember. Okay, no problem. So like from there itself, from known knowledge, given data we are using, and addendum for the wheel is found to be 8.74 millimeter. Next, now we are ready with the addendum. Okay, so now in that, why actually we are finding out all those addendum value and all? Because we already know, like in general, this R value and other RA value actually is required. Okay, in that expression for finding out all those contact ratio and all, where R is nothing but the pitch. We are talking about the pitch circle, radius only. Okay, all those radius in terms of gear or the radius diameter we generally talk about with respect to the pitch circle only. So pitch circle radius. Okay, and the R suffix A, it is nothing but it is the which one? It is the addendum circle radius. So in that particular case, we know how they are actually how we can find out this RA. Actually, RA we can find out by taking this R value plus the addendum value. Okay, so in that particular way we can find out the required RA value. Okay, so because of that only, as we don't have the addendum value here in this particular case, so by the standard expression we are finding out this addendum. That is the that's why we are finding out this AG or this AP, that is the addendum for pinion, addendum for the wheel. Okay, it's not like suppose we know this expression and that's why whatever I am just finding out. It's not like that. We have got the motive. Okay. Next, for finding out the pitch circle radius, we have been given the module value and the number of teeth. So we know R can be given as mt by 2. That is from there module like we already know D by T gives you module. The pitch circle diameter divided by the number of teeth gives you the module. Okay, and D is nothing but this in terms of radius, it is 2R. Okay, so I can write R to be MT by 2. So now the same thing, MT by 2, it is for the pinion, we are taking MTP, okay, the corresponding pair, okay, so MTP by 2, and we are finding out the pitch circle radius value, it is 60 mm. And now addendum circle radius for the pinion we can find out by adding this, okay, the pitch circle radius plus the addendum on the pinion. So just now we have found out it to be 60 millimeter, and in previously we have found out it to be 18.57. So adding them, we can find out the array that is for the small array that is for opinion to be 78.57 mm. Similarly, you try to find out your pitch circle radius for the gear, which comes to be 100 millimeter, and from there the addendum circle radius, by adding the addendum value of the gear to the pitch circle radius of the gear, we can find out this to be 108.74 millimeter. After that, what you can do, you can either you can directly find out your the path of contact by totally actually uh, in the same expression by adding these two, path of approach plus path of recess will actually going to give you, actually is going to give you the path of, length of the path of contact. So that directly you can find out, or one by one you can find out and add them. Okay. Actually, in this particular case, why we are finding out path of approach plus path of recess, these two particular values separately and then adding, because in our question it is given we need to find out the sliding velocity at engagement and at disengagement. So during the engagement part, actually it will be the path, the corresponding path of approach will come into picture, and during disengagement, the path of recess value will come into picture. That's why we are doing both the same, like in a single go. That is it. It's something like egg gully and dosikar. Okay, egg gully dosikar kind of thing. So now for path of approach, we already have the standard expression. We already have used while finding out contact ratio and all. So and now all those values are known. RA is known. R is known. Okay, phi is already given. So other things are known. So directly you can you can get the path of approach value after simplification to be 20.52. Similarly, path of recess also from the pinion values, okay, corresponding pinion values, okay, it becomes small array, this becomes smaller, okay, and all, okay, and we have found out to be 34.220 millimeter. And if we add these two up, we get the total length of path of contact. So path of contact by adding path of approach plus path of recess, we found out this to be 54.72 millimeter. Now, now we have to find out the sliding velocity, and the sliding velocity of the teeth during engagement and during disengagement during this step too. So sliding velocity of engagement, how you can find out? So we already have the sliding velocity expression. If you can recall, it takes care of the addition of this particular omega 1 plus omega 2 into the path of contact actually during that particular time that is required. Okay. So now during engagement, this contact is with respect to path of approach. During disengagement, they are in contact with the path of recess part. Okay, so that is the case. That's why we are the corresponding path of approach and path of recess we are using while finding out the sliding velocity at engagement and at disengagement. So how you can find out? So it is omega 1 plus omega 2 whole into path of approach for the sliding velocity during engagement. Okay, and omega 1 omega 2 just we have previously found out, and path of approach just now we have found out. So this gives you sliding velocity. It is the pitch time velocity. So it is millimeter in terms of millimeter per second. Okay. So similarly, sliding velocity at disengagement, similar kind of expression, but it has to be changed by the path of recess. Okay. The path of approach now it is path of recess. So using the corresponding values which are already found out. So we found out sliding velocity at disengagement to be 5729.2 millimeter per second. Okay. This completes the first part. Now, second part is once again very simple only. We already have so many times we have found out the contact ratio. So contact ratio is given by the length of arc of contact divided by the circular piece PC, the circular pitch PC, P suffix C. Okay. So part of arc of contact is nothing but part of contact divided by cos pi, and circular pitch is pi m. Pi d by t, it becomes pi m. Okay. So it was pi d by t. Okay. And which is d by t is nothing but pi m, so it's equal to pi m. Okay, circular pitch. Okay, and this circular pitch PC. Now from there directly just finding using this particular values, already we have part of context, just now we have found out. Okay, here adding both of them, part of context is found out 54.72. We are using that value and corresponding values of module and pi and all. Okay, and context ratio we have found to be 4.63. Okay, so can anyone tell me if the context ratio is suppose 4.63, what is the meaning of it? What's the indication? What's the meaning? So many times we have found out. Okay, we have discussed, like we have considered 1.7, etc., and we have talked about what's the meaning. Who can tell me? Actually, your voice is distorting. Can you repeat?
Perfectly and 63% engaged.
Okay, still somewhat your voice is distorting. Okay, so don't worry. So I'll be just telling you. So you verify whether whatever you have said it's correct or not. Okay. So actually 4 pairs of teeth you can consider it is always in contact. Okay. And 5 pairs of teeth it will be in contact. It will be engaged during 63% of the time of engagement. Okay, that is what is the meaning. Because half of the teeth or fraction of the teeth cannot be in contact. It's not there is no meaning. Okay, so actually they are the teacher kind of discrete numbers, so like that. Okay, is it the same thing you have said?
Yes, sir.
Okay, and you are correct. Okay, thank you. So I hope all of you have understood this question. Will be able to do solve this kind of similar kind of problems? Do you have the confidence now? Yes or no? Let me know. Have you understood this question? Yes. Okay. Okay. Thank you. So next problem will be going through is it's a simple problem only. Just you should be once you have the idea about the picture, that's how they are engaged and all. Okay, then and if you know about the expression, then actually this problems of gear solving this problem of gear, it's easy only. Okay, you just have the like the module formula you must know. Okay, how and diametral pitch module how they are related. Those things you should know. Similarly, part of the contact ratio and what are the terminologies involving contact ratio. Okay, so if you know this expression, ultimately the various thing that is part of vectors, part of basis, everything you can find out, and from there sliding velocity can be found out. That's because you can once you know about that expression, it's actually it's your job is actually done. Okay, and you should have the clear idea how they are engaged and all. Okay, so next problem, it's a problem from gear train, and it is a problem which came in I think get 2013 or so. Okay, I forgot the year, so we'll go through it. So what's the question is a compound gear train which gears P, Q, R, and S. They have the number of teeth as 20, 40, 15, and 20 respectively for P, Q, R, S. Yes, Q and R are mounted on the same shaft. Okay, so Q and R are mounted on the same shaft means that is the compound gear. Okay, as shown in the figure. Okay, so your job is actually easy. Here the figure is already given. Now the diameter of the gear Q is twice that of gear R. If the module of the gear R is 2 millimeter, find the central distance between the gears P and S in terms of millimeter. Okay, so here the figure is already given, so it's very good only. So PQRS, they are the compound gear arrangement, and R and Q, they are mounted on the same side. Okay, and P is in mass with Q, R is in mass with S. Okay, and gear for gear R, your module is given as 2 millimeter. Okay, so now some of the common knowledge that you should have is like how what is module, how module, and their Actually, the diameter, etc., it is given, right? Diameter of gear Q is twice that of gear R. How actually module and gear diameter, etc., they are related with, and teeth is given. Okay, similarly, what are the relationship that you can have? And apart from that, when you must know, they are asking the central distance between the gears P and F. That means central distance between gear them means center to center. That is the sub of the two. Actually, from here to here, actually they are asking what's that. Okay, and how they are arranged, you can see. Okay, so that is from the knowledge of all those, you can say, the gear, the teeth is given, radius, etc. Some of the relationship is given and all. Okay, so from there you just have to find out the this central distance. So this central distance, if you can know about, suppose from the diameter up to the relationship is also given in terms of for Q and R. Okay, so now one of the way to find out central distance will be if you know, suppose these values, maybe the diameter values or maybe the radius values of these gears. Actually, you'll be able to, by doing addition and all, you'll be able to find out the central, because it's nothing but you can consider as if it's the central distance of, suppose, this one from here to here. If you know radius of, suppose, gear P, similarly if you know about the radius or diameter, anything, they are similar kind of thing only. So if you know for S or R and P, okay, so then also you'll be able to find out the central. Now, how for this, what we are doing, so velocity ratio can be written as in terms of the omega n or maybe n, and ultimately we know velocity ratio we can get omega 2 by omega n, which is similar to like n 2 by n1, that's the ratio, and it is in reverse ratio of that of the number of teeth, and ultimately it gives the indication about the diameter also. So we can write n 2 by n1 equal to t1 by t2, which is equal to d1 by d2. Now we already know module equal to, it is given as m equal to d by t. Okay, so now this is valid for all the teeth, but the corresponding diameter and corresponding teeth you should have. Okay, so now this we are going to use this. Okay, so in that case, what is given for module is given for gear R. Okay, so this suffix there for R means for gear R and all. So from here module for MR equal to dr by tr we can write. So diameter we don't know, but number of teeth it is given as 15. So from here we can find out, we have obtained the dimension of your for gear R. Okay. Next, what is given? So it is given that in the question, the diameter of gear Q is twice that of gear R. That means once we know about gear R, we know also about the diameter of gear Q, which is twice the gear, and it is 60 mm, 30 mm into 2, 60 mm. Similarly, if we they say P and Q are in mass, so solving this kind of problems, okay, there may be different multiple ways. This is one of the way. Okay, how I have solved. You can go in a different manner also, no problem. But ultimately, the logic should be correct, and that's all. That's actually is the mean. So similarly, velocity ratio for P and Q, that particular mass wheel, how we can find out. Okay, in terms of already we have the teeth. Okay, so number of teeth TP by TQ we can write. Okay, so number of teeth we already have, which is 20 for P, and Q for Q it is 40. So it is half, and this in terms of like we can write in terms of your diameter also. So it is same thing. So it can be written like dP by dQ also. That means from this last relation, okay. So what becomes, dP becomes half of dq, that is diameter of q. So diameter of q already we have found out to be 60 mm. So once again the diameter of p, it's also 30 mm. In the similar manner we can find out for this r and s which are in mass. Okay, so about r we already have the data, for from there we can find out the data for s. Okay, so velocity ratio for RNS is TR by TS we can write, which can be written as dr by ds. So TR, that is the number of teeth for R and S, they are given as 15 and 20 respectively, and just now we have the dr value 30 millimeter that we are using. From here we have found out diameter of the critical diameter of the gear S to be 40 mm. So now we have the data about all those diameter for all those gears. Okay, from there very easily the data about your like the radius also by dividing the diameter by 2 we can obtain. And now as we know about the geometrical these distances, we can see how they are related. Okay, and we can get the central distance. This much distance is actually required, and we can see how they are related with respect to the size or the ultimately diameter or radius of these particular gears, the different gears which are in there. Okay, so how we can write this? How we can find out the central distance? Now we can write so the central distance, which is nothing but PS, this distance. Okay, PS. It is not Pranjal Sona, neither it is police station, it is this central distance we are talking about. Okay, so how we can write? So we can add the radius of P, okay, this mass plus radius of S, no problem, this mass, okay, plus the diameter of R, okay, this mass, okay, and then which one is remaining plus this much is remaining. How we can find out this much? It is the radius of Q, the bigger wheel, minus radius of this R. So it gives you this much amount. So this plus this whole thing plus this much is going to give you the central distance. So now we already have the all those diameters. So from there, radius value we can have, and we have found out it to be the central distance to be 18. Or similarly, we can also go through the logic of the similar kind of the mass gears they are having the same module and all. Okay, so that kind of logic also we can utilize. Okay, so that's up to you. So the way you want to solve. Okay, so with this we have completed this problem. Let me know whether you have understood or not.
Understood, sir.
Okay, others. I hope all of you have understood. Okay, if you have any question, any confusion, you can ask. No problem. Okay. Now, this kind of problems you can solve. Okay, you can try solving these kind of problems from any book and all. Okay. So now we'll be going through problems about the different epicyclic gear trains. Okay. So normal gear train, I think for simple gear train is very easy. Okay, you can try for other gear trains also, no problem. But and all. Now we'll be going through the case of epicyclic gear trains. So I think today we'll not be having the time to go through these kind of problems, but I'll be giving you the gist about it. Okay, that is how actually we are going to do the problem, solve the problem. So in those cases, most of the cases, you'll be having the you'll be given the this kind of like the arrangement of the gear wheel, gear train. Okay, and you'll know suppose which one is the which gear is having suppose which amount of teeth and all. Okay, then I'll count the number of teeth, etc. It is given. How they are moving, that kind of thing is given. Okay. So some of the record that I'll be given maybe just like the driving torque in the sun wheel is this much and all. Okay. So we'll go to this problem in details in next class, but I'll today I'm just giving you the overview of it. Okay. So next from this like the arrangement, you must in your mind you must have suppose how actually they are going to rotate and all that kind of image you should have in your mind. Okay. Actually how they are going to behave, or maybe you should know which one is like internal mass, which one is externally massing and all. And if it is externally mass, okay, this one and this one can who can tell me S and P whether they are externally massed or internally massed, external or internal massing? Yes, this wheel, this sun wheel, and this particular planet wheel. Okay, whether they are externally massed or internally massed. Someone said something, but I couldn't hear properly.
Internally.
Internally, who said internally? Is it Khandip? Was it Khandip? Others, what do you think?
Yes, sir.
Maybe same. Maybe this is the same case. Suppose this S that is sun wheel, this is the planet wheel. Azam, Hitesh sir. whether they are externally meshed or internally meshed. This and this, or this and this. For this pair, they are not internally meshed. They are externally meshed. See, the context is here. Okay, Sandeep, is it clear now? Only we are talking about these two pairs, this
Yes,
and this.
sir.
Okay, but if I consider suppose this annular wheel, the outer one, okay, and suppose this one, okay, the bigger ring kind of wheel, annular wheel, and this wheel, then whether they are internally meshed or outer externally meshed. In that case, they are internally meshed because this wheel will have teeth like this, the internal teeth it will have, okay, the bigger wheel, and this wheel actually is having this kind of teeth here, and this become internal meshing. Understood?
Yes, sir.
Okay. And now who can tell me if the two gears, suppose they are gear kind of thing, spark it kind of thing, okay? If they are externally meshed, what will be the relative movement? If suppose one is rotating in the clockwise, what will happen to the other? External meshing.
Anti-clockwise.
Correct. It will be just the opposite, anti-clockwise. Okay. But in case of internal meshing, if one is moving in clockwise, the other one will
Same,
behave.
sir.
Yes. So in that case, internal machine it will be. So this kind of thing you should be able to grasp. Okay. And that is how while solving the signs, that is whether we have to consider positive sign or negative sign, that thing will come into picture. Okay. Depending on whether suppose if I give rotation to suppose one particular gear, what is going to happen to the movement about the second gear. Okay. So once you consider the proper sign and all, then rest is easy about your like this episodic here. Rest is easy. Step by step, we just go. We conditions of motion, different conditions of motion we consider. Then the various elements which are there in this particular epicyclic gear train, we just consider. Okay, suppose this three numbers of planet gears, sun gear, the external gear, okay, E, okay, and the annular gear, and this R. So that is how we consider. So right now here in this particular case, all those gear P, those are the planet gears, these three, this one and this smaller gear, this and this, they will behave in the same way. That's why if you consider anyone and analyze them, it will be sufficient. This one other will behave in another way, and the sun gear will behave in another way, and the arm it is holding them. Okay, so that is how I will be considering different conditions of motion, and we'll see what will happen to the suppose one is within some motion, what will going to happen to the other, and because of that, what is going to happen to the other and all. Okay, that kind of thing we'll do, and after that, whatever is the given conditions, we'll try to fit with the given condition from this particular chart, and we can find out the whatever is the required answer. Okay, this is how we are going to solve this kind of problem. So with this, we'll stop here today. In the next class, we'll solve epicyclic gear problem. So if you have any question, you can ask me, or if you have understood, you can let me know whether you have understood or not. Okay, yeah, I hope all of you have understood. So with this, we'll stop here for today. Those who have not submitted assignment, submit it by today. Okay, thank you.